Hello, I'm Ralph Shattuck, Regional Market Manager for BG. I'm also a trainer at BG University. And what I want to do is talk to you today about the properties and the cleaning ability of 44K. Before I can show you the cleaning ability of it, I need to show you how deposits form and what their chemical base is of those deposits. So to do that, I'm going to need some 44K, some gasoline or petrol, preferably in an applicator bottle, it makes it easier, my ever-trusty bottle of acid, which we remove the top before we start, so that we don't scramble and trying to find ways to open it when we've got something in our hands. A test tube. Test tube stand is optional in this. We also need a stopper to go with it. We need a heat source and our lovely disposal. The last thing I need is my glasses. Okay? 2 reasons, so that I can see what I'm doing, but also for protection. Okay? And you should do this sort of thing too, because we're dealing with sulfuric acid. So, here's how we proceed from here. First of all, I take a clean test tube, as you can see. It's nice and clean. We add just a standard sample of petrol, gasoline, benzene, whatever you want to call it. You can do this process as well with diesel fuel. Whichever you want to do, it doesn't matter, using 244 instead of 208. Now, I take my sample. I have already tested it, so I know how it reacts. Please don't go in there and try it with some other samples. You don't know what people have put into it. Take your own. 2 drops of acid. 1, 2. Then we shake it up. You can sing with it when you do it, or you can not sing. Yeah, shake it up, okay? We can do all these sort of things with it. We agitate it. What we're doing now is we're causing the fuel to oxidize. We're breaking it down its component parts. Up until about 1974, we only used about 11% of a barrel of oil to actually make petrol from, gasoline from. But after that point, we started to blend the fuel, and we mixed together some of the light stuff with some of the heavy stuff. The light stuff being propanes and butanes, which we used to use for cooking gases, and the heavy stuff being tars for the roads and things like that. Okay? Now look at this test tube. Can you see this white sort of slime that's forming on the side of the tube up here? Okay? It's not a great deal at the moment. We don't see it like it used to be because we have ethanol in here. So it doesn't show up as badly as it used to. But we're actually, the more we do it, the more forms. Can you see that sort of thick sort of treacle? Those are actually olefins and diolefins that are dropping out of the fuel. These actually have other uses too. Making carpet is one of them. It's a man-made product to hold the light stuff together with the heavy stuff and stop them from separating. So here we go. We're getting some nice deposits forming in here now. You can't really see them quite that well from where you're sitting back there, but I can assure you I can start to see them. Okay? I want to get some towards the top end because I'm going to make deposits there. Okay? Now I take my heat source and add some heat. You will get a little flame out of the top. You don't want to set the world on fire doing this. Sorry about that. Okay? Now we have, as you can see, carbon forming on the top of that combustion, in the top of this test tube. This is only a little bit of product that we're using, okay, but we had a tiny little bit of fuel. Now, every time I stop the engine, and my engine does a heat soak, I pour some more of this over it, and some old fuel over it, and we start to get more deposits forming. You can see how yellow this stuff is becoming in here. And every time you stop the engine, if you've got carbon on there, the little bit of fuel soaks into it and creates more and more deposits. so that your deposits grow on a curve like this. Nothing at the beginning, a little bit next, and then it grows like that. Okay? So, what happens inside your combustion chamber? On top of the piston, you have a couple of thousandths of gap. When the piston comes to top dead center, you only have a couple of thousandths. What happens if I start forming deposits on there like that? I've shut down that gap on top of the piston, which then we do not get a proper burn, so my timing retards on the vehicle. Okay? When you retard the timing, you lose power. You have a choice. You can bring back the timing by increasing the octane of the fuel, or you can clean it. If I increase the octane, it's going to cost me 20 cents per gallon more to get the same out of my car as I got before. Okay? If I clean it, I'm going to go back to where it was at the beginning. According to Chevron, 1 can of 44K polyetheramine will reduce the octane requirement of an engine by up to 6 octanes. That's a lot. 6 octanes. So let's see what fuel on its own does. I put some new fuel in there. I can first of all, you have to be a little careful because this test tube is hot. Okay? So we shake it up a little bit to cool it, and then you can see you can remove some of it with the fuel. But look at the inside of that test tube. What's happening to it? We've just washed it into the fuel. Now that will end up going down into your injectors, into your catalytic converter. That's not a good idea. And we're also starting to form more slime in there because we've still left old oxidized fuel behind. Okay? It hasn't gone anywhere. So what we got to do is get rid of that. I'm going to use a dropper to put some 44K in there. I don't want to add too much because, as I said, we only need 1 can for every 20 gallons of fuel. So we don't need much at all to make this happen. First of all, when I shake it up, I'm going to dissolve in all of that light product, all the olefins and diolefins that were sitting on the side of this test tube. Okay, so we'll reabsorb that back into the solution here. You'll notice the solution hasn't really changed color at all. It's nice and clean. Inside the combustion chamber, though, where the carbon is, the product is much harder. Carbon is much, much harder, second in hardness to a diamond, as fact. So how can I get rid of that? I can't really show you too well. So what I do is I've made the deposits towards the top of the test tube, and then if I go in there with my finger, you can see the carbon actually wipes off as a powder on my finger. Now a powder will be carried by the 44K down through the system and go completely down through the catalytic converter. Okay? It's not going to stick in the catalytic converter because every molecule of carbon is separated from the other molecules. It acts as a dispersant. Okay? So we do it a step at a time. We shake up that 44K in there again, we get some more flowing over the carbon, and a little more starts to break loose each time. So my finger gets a little dirtier and a little dirtier, and gradually we'll end up with nothing on there at all. But it goes down through the system, cleans it slowly, so that we do not get any problems inside the system. The best thing you can do after you've cleaned this test tube up to your liking, and you're going to have a little bit of soot left from the torch. Okay, you can't do much about that from heating it. The best thing you can then do is get an old valve or a piston top or a cylinder head that has a nice lot of carbon on it. Pour this solution, which you've already used to clean up, over the valve. Let it sit for a second and you can start wiping the carbon off. And it comes off as a powder on your fingers, just like that. If it's stuck back together, it would cause a problem. The best analogy I've got for 44K and the way the chemistry works, if I have little pieces of chocolate in my hand that are separated, okay, and in this hand I have M&Ms which are coated. If I put this one under heat in this hand, within a few minutes they stick back together, they re-agglomerate, and they would cause problems if it was going through your catalytic converter honeycomb. The M&Ms though, same amount of heat, but they stay separate. That's exactly how a dispersant chemistry works in 44K. It keeps everything separated so it does not re-agglomerate and carries it out the tailpipe.